All right, y'all. 3.6 is titled Solving Applied Problems. All right, so like I said, continuation of 3.5, except these are more word problems. So I'm going to do the type of word problems y'all going to see on the homework, and these will start at like number 3, 4, and 5. Number 1 and 2, you're just figuring out what the written statement is and writing it as an algebraic expression. So, sort of like on the support we did the other day. So, I'm going to actually do the 3 word problems you're going to see that involve the systems of equations. All right, y'all. So, my first problem says in triangle ABC, the measure of angle B is 29 degrees more than 3 times the measure of angle A. All right, so there's the first sentence they gave me for my first equation. Now it says the measure of angle C is 61 degrees more than the measure of angle A. All right, so they gave me these 2 sentences. Then it says find the measure of each angle. All right, so just remember we're dealing with a triangle and it has 3 angles. Now, since we got 3 angles, we're going to have 3 equations on this. Okay, remember, to solve a system of 3 variables, we need 3 equations. So let's write what we got first. So this one says B is means equals 29 more than 3 times measure of A. So that would be B equals, so you can either do 29 plus 3A or you could do 3A plus 29 either way. Okay, that's what we're getting out of the first sentence. The second sentence says that angle C is equals again 61 more than A. So that would be C equals A plus 61. All right, so I'm going to bring up chat so y'all can sort of answer some of these. What I need to know is I need 3 equations if I'm going to solve this problem. So, y'all, what do y'all know about the 3 angles of this triangle? Because we need another equation. All right, y'all. So, what do y'all know about these 3 angles? Maybe I'll ask y'all this. What do the 3 angles of a triangle add up to? All right, definitely 180, y'all. Good job. So that means A plus B plus C equals 180. Now, I'm going to rewrite this and get all my variables on one side equal to the number. So this one's in the correct order. So I'm going to bring up A plus B plus C equals 180. Now, y'all, this one I need the 3A on the other side. And on the second one, I need the A on the other side. So if you move anything from one side to another, you change its sign. So since I'm moving the 3A to the other side of the equals, that's going to give me a negative 3A plus my B is going to equal 29. So that's what you would have got if you subtracted 3A from both sides to get to 29 by itself. Now, y'all, the same thing here. I'm going to move this A to the other side. If it's positive on that side, it's going to be negative on the left side. So that's going to give me a negative A plus my C is going to equal 61. So remember, moving a variable from one side to the other just change its sign. Okay, so that's what we did with the 3A made it negative. This A made it negative. Now, I've got my system right here that we're about to solve. Now, I'm going to show y'all a trick on this one. Since this second equation is missing the C, and this third equation is missing the B, I'm going to eliminate either the C or the B, because if you do that, you only have to do the elimination once, and then the other equation you didn't use will become the second equation automatically. So let me show you what I'm talking about. So y'all, either the B or the C I'm going to eliminate. So how about I eliminate the B? So I'm going to eliminate B. So first, I'm going to add these two equations, but notice that B is positive and this B is positive. So if I'm going to eliminate the B, I'm going to multiply this second equation by -1. Okay, because remember, I need this one to be negative so that it'll cancel with that one. So the first equation I'm not changing. That's going to be A plus B plus C equals 180. Now multiplying the second equation by -1, negative times negative makes that a positive 3A. Negative times positive makes that a negative B, and that's what I needed. And then a negative times 29 makes that a negative 29. So distribute whatever you're multiplying by through the whole equation. All right, y'all, let's see what we get. 1A, 3A give you 4A. The B's cancel. I got a plus C, and that's going to equal 180 minus 29, which gives me 151. All right, y'all. So now, remember, all the equations got to be used, but y'all, this third equation that I haven't used yet, it does not have a B, so I can automatically bring that equation down. So let me write the one we just got. I can automatically bring this equation down, negative a plus c equals 61 as my second equation. Okay, so you only had to eliminate by adding the two equations one time. The third equation automatically comes over. All right, now on this one, you can either eliminate the a by multiplying the second equation by 4, or you can eliminate the c by multiplying one of those by negative 1. So, y'all, I think I'm going to eliminate the c this time. So I'm going to multiply the second equation here by negative 1. So I'm not changing the first equation. 4a plus c equals 151. I'm going to change this one. Negative times negative makes a positive a. Negative times positive makes a negative c. Negative times positive equals a negative 61. All right, y'all, so let's add these and look here. Them C's are going to cancel. So 4 plus 1 gives me 5a. 151 minus 61 leaves me 90. So I'm now down to one variable. I'm going to solve for a by dividing both sides by 5. So that cancels, giving me 1a. 90 divided by 5 gives me 18. So I know my angle A. Now, y'all, what's nice about this, I can put an A here and get C real quick. I can fill in for A here and get B real quick. So I don't have to do as much strenuous back substituting since I got missing variables on this one. So let me come up here and start back substituting. All right, so first I'm going to grab this, and it's real easy. C equals A plus 61. Well, A is 18, so I'm going to put an 18 in, add that to 61. All right, y'all, so adding those, I get what, 79 on that? So now A is 18, C is 79. I'm going to get B now. So I'm going to back substitute to get the B. And B was 3 times A plus 29. So that'll be 3 times my A, which was 18. Whoops, make that a curve. Plus 29. So when you're substituting back, you could use any of these three original equations, or you could have used any of the three that we solved. It don't matter as long as it's one of these equations, okay? All right, so 3 times 18, y'all, is what, 54 plus 29. All right, y'all, let's see. 54 plus 29. That's going to give me 83. So in MATLAB, it'll have A equals, B equals, C equals. We got 18. Angle B, we got 83. Angle C, we're going to go up here, 79. If you were to add all three of these angles together, those would equal 180, like y'all told me a while ago. So let me show you this one on the calculator. Now, if you do it on the calculator, it's got to be in the right order right here. You got to have all the variables on one side equal to the number. But y'all check this out. Let me ask y'all this. Right here, I would put a 1, 1, 1, 180 when I do it on the calculator. Right here, I would do a -3, 1. What would I put in place of this C right here? What do y'all think? Because remember, there's no C there at all. So what are y'all putting? You got to put a 0. Good job. So any missing places when I do them on the calculator, I'm putting a 0 in, okay? So y'all let me pull up the calculator and give y'all more practice doing this. All right, so we're going to hit second, x-1 for the matrix. We're going to go over to edit and hit enter. All right, so these are 3 by 4. Anytime you got 3 variables, it's a 3 by 4 when you're solving equations. So enter on 3, enter on 4, and then we start putting our numbers. 1A, enter. 1B, enter. 1C, enter, equaled 180. And enter. My second equation was -3 for the A, 1B, 0 for the C, and that one equaled 29, enter. My third row had a -1A, so -1, enter. 0B was there, so 0, enter. 1C, enter, and then 61, enter. All right, y'all, all my numbers are in, so now I quit the screen by hitting second mode. All right, so the matrix is in there. Now we're going to go get the math for it. So we're going to go to second, x-1 for the matrix again. We're going to arrow to math. And then remember, once I got math highlighted, I'm going to arrow down and get RREF and hit enter. So now I just got to grab that matrix. So I'm going to hit second, x-1. So I always use A for my matrix. So when you pop this up, all you got to do is hit enter, and it'll bring your matrix A to the screen. Now y'all remember, it's going to put my answer in alphabetical order from top to bottom in the right column. So when I hit enter, y'all, there's my 3 angles, 18, 83 for B, 79 for C. So not bad either way. If you like doing them by hand, that'll work. A lot of times I do them by hand and then I check them with the calculator maybe, but y'all either way you want to go. All right, so let's try our next example. All right, y'all, this one says the sum of 3 numbers is 57. Then it says the difference of the largest and smallest is 52. Now, then they say the sum of the 2 smaller numbers is 13. Find the numbers. Now, MathLab is going to want us to put the numbers in order from largest to smallest in the answer blanks. So, Since I'm dealing with three numbers and they're talking about large number, small number, and all that fun stuff, I'm going to set my variables up. X's will be my largest number. Then I'll have my middle number and my small number. So X's will be large, Y's will be the middle number, Z's will be my small number. So the sum of three numbers is 57. What would that equation look like? So the key word here would be sum. And y'all, I'm going to use X, Y, and Z for my variables, okay? All right, remember, sum means they're adding these numbers. So for my first equation, I'm going to have X plus Y plus Z equals 57. All right, Darren, you got it up there. Let me see. Yeah, perfect. Perfect. Now let's get this second one. The difference of the largest number and the smallest number is 52. So they're talking about the difference. So what do y'all think I'm going to put on that equation? Oh, you're so close, Jan, but remember, they got difference up here. So you got the X perfect, but that Z, there you go, needs to be subtracted. So your Z's got to be negative so that you got subtraction going on. And then that one will equal 52. All right, here comes the last equation for y'all. The sum of the two smaller numbers is 13. So once again, sum is getting back on that adding. So what would this equation look like? Perfect. Y plus Z, right? That's my two smaller numbers. Y plus my Z, that's going to equal 13. So y'all look, this one has a missing Y and a missing X. So we only got to do the elimination one time. Since we got missing variables. Now I'm going to say this one wouldn't be too bad. You could do the Z, but you would have to use all three equations and eliminate it twice. So you can still do that, but it's a little bit more tedious, okay? So I think I'm going to come in here and eliminate a Y. Now, if I eliminate a Y, I'm going to take this equation right here, because that's a Y and a Y, they're both positive. So I need one of them to be negative. So I'm going to change the last equation by multiplying by -1. So my first equation will stay the same. X plus Y plus Z equals 57. We're going to distribute a -1. I get a negative Y. I get a negative Z. And that's going to equal a -13. But y'all, if y'all just set up like me, watch what happens. What happens here, y'all? Look at that. My Y's cancel. My Z's cancel. So I've already got this solved for X. X is going to equal whatever 57 minus 13 is. And that's going to give me what, about 44. So if you pick the right variable, this stuff cancels a lot out, okay? So I'm pretty sure y'all's will be the same sign as mine. So y'all cancel the y out, and it'll also cancel the z out, okay? All right, I know what x is. I'm going to back substitute. Well, since I know what x is, I can put that right here and solve for z. So I'm going to put 44 in for x, okay? Minus my z is going to equal 52. All right, y'all. So solving that for z, I'm going to subtract my 44. Well, that'll cancel. I get negative z equals 8. And y'all, let's make z positive by dividing by negative 1. So that gives me a positive z equal to a negative 8. So look here. I know z now. I can solve this one for the y. So I'm going to back substitute to get that one. So y plus z will be y minus my 8 equals 13. All right, also to solve that, I'm going to add 8 to both sides. So that I get my y, that cancels. 13 and 8, 21. So Math Lab will say the numbers largest to smallest are blank, blank, blank. All right, well, I know my largest number was my x's, so that's 44. My middle number was the y, that's 21. And then my smallest number was the z, and that was negative 8. Y'all, if I add these three numbers together, they will equal 57. Y'all, these aren't bad. It's just getting them equations set up and looking at these keywords like sum and difference on those, okay? And then remember, is always means the equals. All right, y'all. So on the calculator, you would punch it in 11157, 10, negative 1, 52, 0, 1, 1, 13. So type them in before you change anything, okay? And then go in and get that RREF, and it'll spit out these three numbers on the right side, 44, 21, negative 8. All righty, y'all. Next example. So this will be the last example for 3-6, and then we'll look at 10-2 real quick. 10-2 is pretty easy. It shows you another thing you can do with these matrices. All right, y'all. Eating one egg, one cupcake, and one slice of pizza. A child consumes 301 milligrams of cholesterol. Now, the second sentence says if a child eats 3 cupcakes, 4 slices of pizza, they consume 82 milligrams of cholesterol. All right, then my third sentence says, eating 3 eggs and 1 cupcake, the child consumes 846 milligrams of cholesterol. So we know what you're going to ask. How much cholesterol is in each item? So since we're talking about eggs, cupcakes, and pizza, I'm going to let my eggs be my X's. My cupcakes will be my Y variable. The pizza will be my Z variables and then whatever they equal. So y'all, for my first sentence, X plus Y plus Z equals 301. All righty, my second equation, 3 cupcakes and 4 pizza. That'll be 3Y plus 4Z. That equaled 82 milligrams. And y'all, here comes our third one. 3X's plus 1Y. For my cupcake, that row equaled 846. All right, so y'all, let me ask y'all this. Are y'all doing this by hand, or is everybody doing it on a calculator? Everybody doing it by hand? How are y'all working these? So y'all just chat me how y'all are doing them. Hand or
By
say again?
hand.
By
Bye.
hand? Yeah. I'm always a hand person myself. I don't mind using the calculator to maybe check me or something, you know. All righty. So here's the question of the day then. Since we're doing this by hand, what variable do y'all want to eliminate? All right, so you got 3 choices, X, Y's, or Z's, y'all. So what are y'all eliminating? I'm trying to sort of see how y'all are thinking about this. Now y'all know there ain't no wrong answer, right? All right, I'm gonna do X's. Good. So I would either probably chose X's or Z's. They would have been a lot easier. Um, but you could have went for the Y's. It would have worked. So let's eliminate X. So if I'm going to eliminate that 3X, what would y'all multiply this first equation by? If I want to eliminate 3X here. So -3 sounds good to me. So we're going to multiply the first row by -3. So I'm going to get -3X, -3Y, -3Z. That's going to equal a -903. Now I'm not changing to the last row, so that's 3X plus Y equaled 846. Hey, y'all, good job. The X's are gone. -3 and 1 give me -2Y. Bring down my -3Z. And then let's see, what do we got? 903 negative and then 846 positive, I get a negative 57. But y'all look at here. The second equation that I haven't used yet, it does not have an x, so that second equation automatically can come down and be the second equation for my system. So I got a 3y plus a 4z equals 82. Okay, so on this system here, we got to either eliminate the y or the z. And y'all look at this. No matter which variable I pick, I've got to change both of the rows. Because -2 and 3, I'd have to change them both into sixes, make one -6, one +6. If I did 3 and 4, I'd have to make one of these a -12 and a +12. So it's almost like finding least common denominators when you're trying to figure out what numbers you're going to turn them into, okay? So watch this. I'm going to eliminate the y. So both rows got to be changed. So the top row, I'm going to multiply by 3. That'll give me a -6. This bottom row, I'm going to multiply by 2, because 2 times 3 will give me 6y. So distribute through, I get -6y minus 9z equals, so what I got there, -57 times 3 gives me -171. I'm going to multiply this row by 2, so I get 6y plus 8z equals 164. Oh, y'all, look at that. The y cancels. -9 and 8 give me a -z. -171 and 64 give us a -7. So we got one step to solve for z, and that's to divide by -1. So that now is a positive z equal to a +7. So we know what z is, we can now back substitute. So if I put in for this z, I can solve for that y. So I'm going to do 3y plus 4 times z, which was 7, equals 82. All right, y'all, so let's see. We're going to multiply first. So bring down to 3y. 4 times 7 is 28. That's going to equal 82. Now, let's subtract 28. So that brings down to 3y. Oh, I think this is what, 54? Now, divide by 3 and we have our y. And y'all, 54 divided by 3 gives me 18. So Z was the pizza. It's only got 7 milligrams of cholesterol. Y was the cupcake. It had 18 milligrams of cholesterol. So now we'll back substitute so we can figure out these eggs. So 3x plus my y, which was 18, that's going to equal 846. And y'all, let me say this on this one. Since we're dealing with how much cholesterol is in each of these, all these answers got to be positive, okay? So just like the one with the triangle, All three of them angles in the triangle had to be positive. The only one where you'll get that negative answer was that one where we did the three numbers, had a sum of. One of those was always negative, and the other two were positive. So, not going to see many negative answers today, okay? All right, y'all, let's solve this. Subtract 18 from both sides. That's going to give me my 3x. 846 minus 18 gave me 828. All right, divide everybody by 3 and see what we get. So 828 divided by 3 gives me 276. So Math Lab will have the egg equals pizza. Whoops, next was the cupcake. And then the cupcake equals, and then the pizza equals. So my egg was 276. Cupcake was my Y, was 18. And then pizza was my Z, was 7. Anyone want to see that one on the calculator? All right, so I'll spit it out real quick. So let's share that calculator. Now, before I share it, let's remember I'm going to do 111 301 0 3 4 82 310 846. So I'm still using zeros for the missing placeholders. So y'all let me clear everything out. All right, here we go. Second, x negative 1. We're going to go to edit and enter. It's a 3 by 4 still. So let's see, I had 111 301. So I'm going to enter, 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 and then that was 301. And enter. All right, my second row was 0, enter, 3y, enter, 4 for the z, enter, and that one equals 82, enter. All right, my last row, 3 for the eggs, 1 for the cupcake, 0 for the z. That one equaled 846, enter. So you enter everything you got to put in it. On mine, that cursor goes back up to the top left, which means you're done. So now I can hit second mode and quit. All right, let's go get to RREF. So second, x negative 1, highlight math, and then we're going to go down and get RREF. And enter. And y'all finally, second, x negative 1, my A matrix is highlighted. I'm going to hit enter. That brings it on the screen. And now I'm going to hit enter and get my numbers. So see how the 1 in the first column, that was the egg column. So one egg had 276. The 1 in the second column, if you go right, so one cupcake was 18. And then since this last one is in the last column, that meant one slice of pizza was 7 milligrams. So, they're not bad. Just got to set them equations up, and then no matter how you're solving it, knock those out, okay? So that was 3.6. Now I'm going to get us going on 10.2. And y'all, we're actually going to work the problem like it looks in MathLab. So let me get MathLab set up for this. All righty, so let me share my screen. All righty, so I'm going to write this example down and then show you what they want. So they ordered 40 pounds of tomatoes, 30 pounds of zucchini, and then 50 pounds of onions. Now, A, for A, they want me to write a 1 by 3 matrix that represents the amount of each. And then what's it say? Of each item ordered. Okay, so I'm going to go back to my pad and show you what we're going to do to this. Now, since we're dealing with a matrix, matrices are represented by brackets. And I'll show you what tool you got to use in MathLab to get this thing like this. Now, 1 by 3 matrix, remember, it's the number of rows by columns. Just like the ones we did a while ago that were 3 rows by 4 columns. These will be 1 row with 3 columns. So it's going to look across like this. Now, all we got to do, since I got 3, when you do this, you'll get 3 squares like this. All we're going to do is put the amount of each in one of these squares. So 40 will go in the first square. Then 30 in the second box. And the last box was 50 pounds of onions. So I would put my 50 in the last box. So when they say write a 1 by 3 matrix, they want 1 row with 3 columns in it, okay? So let me show you how you're putting this in MathLab. So you're going to click in the answer blank. When you click that in, down here, you get options. You got the fraction option, mixed fractions, superscript for exponents, absolute value. Well, I'm going to arrow on down to the one right before more. If you click on that, it says matrix. So y'all, click that, and then look what it says for the matrix. How many rows do you want? Well, we're going to arrow down because we wanted 1 row. And then it says how many columns? I'm going to arrow up because I wanted 3 columns. Y'all look, there's my matrix with my 3 boxes. So I hit OK. It brings it into the answer blank. And now you just got to put in your amounts. I had 40. I had 30. And then the last one had 50. So This is how much was ordered for that week. 40 pounds of tomatoes, 30 pounds of zucchini, 50 pounds of onions. So y'all, at that point, we're going to check our answer. Now look here for part B. Let me write B down here. B says the following week. So the following week, the produce manager increases by 10%. So find the matrix B that represents this order. So it's going to be the same three entries. So let's go back to the pad. All righty. So all we're doing is increasing each of these items that we ordered this week by 10%. So we're still, I'll make it a little bigger this time. We're still going to have 3 boxes in here. So y'all, there's 2 ways to do that. You can figure out what 10% of 40 is and then add it to 40. 10% of 30, add that to 30. 10% of 50, add that to the 50. But y'all, let me show you a quick way. If you're increasing an order by 10%, all I got to do to each of these numbers is multiply by 1.1. Because that 0.1 represents my 10%. So let's see, then we had 30 times 1.1, and then 50 times 1.1. So y'all, what is 40 times 1.1? So that'd be 44. So that makes sense. 10% of 40 is 44. I mean 4, and 40 plus 4 give me 44. So my first entry would be 44. All right, y'all need 30 times 1.1. So 33, good job. 10% of 30 is 3. Plus 30 gives me 33. And then finally, how about 50 times 1.1? 55, there we go. So anytime you increase something by 10%, I do like 1.1. If I was increasing by 20%, I would do 1.2 and so forth, okay? All right, y'all. So there is our matrix B we can put in. So let's go to Math Lab, put in that matrix B. Now remember, I'm going to come down here and get the matrix tool. I'm going to make that one row again, and then arrow up and make that 3 columns, and enter. So y'all, our amounts were 44, 33, 55. So we're going to check that answer. So now let's see what they want for C. They wanted me to find A plus B, and then tell what the entries represent. All righty, so let me go share that real quick. All right, so when you add matrices, they got to be the same size, okay? So what I'm going to do, A plus B will give me a matrix that is still going to have 3 places in it. Now, when you add matrices, you add the first column with the first column, get that answer. Then I'll come in and add the second column with the second column, get that answer. And then finally the third column, I'll add them together and get that answer. So when you add a matrix, the place values add to the same place value, okay? You can never add the first column with the last column. It's got to be the same row and same column. So y'all, knowing that, what's going in that first box? 84, perfect. All right, get my second box. So 63, there we go. So 30 and 33 gave me 63. And y'all, my last one was what, 50 and 55? So that'll be 105. So this was the order for the first week. This was the order of the second week. This matrix represents the total order for both weeks. So this is the total order for both weeks. All right, so we want MathLab to have some kind of answer similar to that. So let's go back and see what MathLab's doing. First, it looks like we're putting in our matrix we got. So come down here and get the matrix tool. Now, y'all, let me tell you this. These answers will not work if you use the brackets on computer brackets. You cannot use the brackets. You gotta physically use this matrix tool, okay? It'll mark it wrong if you use the brackets on your computer. All right, so once again, make that 1 row by 3 columns, hit enter, and then y'all put in your numbers. We had 84, 63, and 105. So see, you check that first, then it says, what are we picking, A, B, C, or D? And we sort of said what we was going to pick on that, right? So it can't be A because it ain't to change. That last matrix didn't represent the change between them. Can't be B, right? We didn't even talk about the third week. So what are y'all saying? D, let's see, D represents the total produce orders for the 2 weeks. Yeah, that's exactly what we said. We had a first week's order, second week's order. When we added them, we had the total for 2 weeks, okay? All right, y'all, so then you check that answer and you be done. So that was 10.2. So y'all gonna love 10.2. It's pretty quick. Um, you just get in there, put the first matrix, but remember, use the matrix tool in MathLab. Okay, do not use them brackets on that keyboard. All righty, y'all. Guess what? Next week we finish out the first test material on Monday. We'll knock out 3-7. And then Wednesday, we're reviewing for test 1. And test 1 will be due, what is that, the 15th, I think that's Sunday. Yeah, I think that'll be the 15th. So test 1 will be due the 15th. So if you're behind, you want to get caught up really quick so that all you can focus on next week after 3-7 is focusing on that test, okay? So that's what's coming up next week. 3-7 and reviewing for that first test so y'all can knock that out.